Thanks, everybody. I appreciate that. Good afternoon. Hope you had a good lunch, had some good coffee, and let's go ahead and dive in, shall we? So for those of you that are interested in this topic, and I assume you are since you're sitting in here with me, I do have a companion ebook that goes along with this. I wrote this slightly earlier this year. I think it came out the middle of May, end of May, something like that. So if this topic is of interest to you, feel free to head on over and get yourself a copy of this at your leisure. So the longer I do this, the more I realize that this architecting thing is actually kind of difficult. When I first kind of got into software and first interacted with an architect, I thought, oh man, that's the job I want. I get the technical autonomy. I get to make the tough technical decisions. And then I became an architect and I realized, God, it's a lot harder than that. I've got to deal with all these messy agendas and all the politics that goes along with any number of people in a room. And then I realized really quickly that, man, technology changes, doesn't it? I mean, every time I turn around, there's a new technology. Now, I would argue that that's a feature, not a bug, that it's actually what draws a lot of us into this industry, the fact that there's always something new to learn. Just look at the agenda for our show here this week. And how many new topics are on here that you maybe didn't think about before you showed up. And you come here next year and there's going to be a whole new slate of topics. Now one of the challenges we face as architects, as senior technologists, is dealing with the fact that we really want to avoid legacy platforms. Nobody wants to be on that platform where you can't hire. Nobody wants to be on the team. You got people fleeing. I see this a lot in big enterprises where you have this one legacy or heritage system, if you want to be more positive. And boy, it's really hard to staff that team. We've only got 2 or 3 folks left, that know the system. And so we really want to avoid having these legacy technologies in our organization. But by the same token, I can't just change things willy-nilly. I can't just change things every few months because I feel like playing with something new. I can't practice resume-driven design, and I've seen that a lot in my career. People who pick a technology simply so they can put it on their resume and say, yes, I've played with insert technology X here. If we're not careful, we end up where one of my students was last year when she told me that her application had 4 separate UI frameworks in it. And I completely understand how that happened. Because developers just wanted to keep playing with the new thing. The first person probably used Angular, and the next person used React, and then the next person used Vue. And the next thing you know, you've got an application that's really hard to maintain over time. And the other problem is they didn't have anybody that was really empowered to say no. Now, one of the things that I've noticed is that it's becoming a little trendy for organizations to say, we don't have architects. We're agile. We don't have architects. And I always find that kind of amusing because the reality is whether you have anyone in your organization with the title architect or playing the role of architect, you have people on your projects making architectural decisions. We sure hope they're making good ones. So how do we avoid being in this situation where, again, we don't want to be on a legacy platform, but we can't just change things every few months because we feel like it? And one of the things that I've learned the longer I've been in this industry, that I don't know what the next technology is going to be, but I sure as heck know there will be one. And the challenge for me, the challenge for any of us is how do we evaluate that next technology? Now I wish I could predict the future. I wish I had an idea of what was going to be the next language, platform, etc. But I don't. No one does. The one thing I'm very confident is, the one thing that I can guarantee you is that it will be different than what we use today. There's a virtual 100% chance that 5 years from now, we're going to be using something that hasn't even been invented yet, that we're not even thinking about. That's not even on our radar screen, and that's going to be the big thing 5 years from now. So the first part of this for me is, how do we avoid, or how do we be very proactive in how we sort of evaluate new technologies, decide what technologies make sense for us and our project? And again, this is not new. If you've been in software for more than 5 minutes, you know that things change. I didn't always appreciate that. Early on in my career, I missed some wave. Some new technology came along and I didn't get on it quick enough. And I thought, oh, you know what, there was my one chance. That was my opportunity. And I quickly figured out that, no, it's not. Technologies are a lot like a bus. Another one's going to come along in 10 or 15 minutes. You just have to be patient. And when you've been in this industry long enough, you start to appreciate that these things repeat and that technologies have a tendency to come back and get a new name. And eventually you start to learn which of these technologies actually make sense. When do I let one go by? When do I decide this one's really not something I'm that interested in? Or I've seen how this movie ends, so I can avoid that. So this is a constant, and it is very tempting for us to always want to chase the new hotness, to be on the latest and greatest framework. And many of us very much want to be on the bleeding edge. And I get that, but it's ironic to me that the word bleeding is right there in the name, and yet this is where we want to be. We need to be a little more considerate. Sometimes being on that 0.04 technology might not be the best idea. Now, I get it. It's fun. It's an interesting thing to do. It's what stimulates a lot of us, mentally, and it's always fun to play with something new. And quite frankly, it is part of being in this industry. You have to be able to adapt to new things. You have to be able to learn new things. Now, in my career, I think I can count on one hand the number of developers I've encountered that really struggled learning new things. And in at least one of those cases, it was willful. The guy just didn't want to learn, in this case, Java. He was very happy as a COBOL programmer, and that was enough for him. But what's interesting is to see how over time our understanding actually evolves. And so there's this great Twitter thread I ran into earlier this year, and it was from Ben Evans, who's a fantastic guy. I highly recommend you follow him. But he said, there's these things you understand well enough to have an opinion on. There's things that you know just well enough to know what other people's opinions are, and then there's other things where you have no opinion at all. And of course, the challenge here is technologies are moving in between these categories all the time. And he goes on to make a really good statement, which is there's things that we're just starting to learn about. There's things that we know really well. There's things that we don't follow anymore. There's things you used to be an expert on, but you don't know anymore. I used to do a lot of jQuery. I haven't touched jQuery in years. So our industry throws away knowledge really quickly and all the time. That's one of the challenges we have, is understanding that, I used to know a lot about that, but I don't anymore. I'm not sure what sort of the top of the status is. I don't know what the current thinking is in that space. Now, let's be honest. As developers, we have opinions, and we often have very strong opinions. Tabs versus spaces is a perfect example. Now, I also think part of this is this sometimes irrational fear of things that are old. And I don't entirely understand this, but I think at some point in our career, we've all had this conversation with somebody that's more senior, and we've kind of had it drilled into us that you don't want to have a legacy skill set. You always want to have fresh skills. You want to be at the top of that. You want to be very marketable. You don't want to have that legacy skill as your defining knowledge base. And I think that's a little interesting because, again, I ran into another Twitter thread that wasn't specifically about this, but hit on some really good points, which is maybe we're afraid to learn old things for some reason. Because we think the old is always more complex, always more arcane, but the new is always simplistic and elegance. Except, let's be honest, a lot of the new technologies have a lot of rough edges on them because they're new. Whereas the older, more proven technologies, a lot of those rough edges have been buffed off. And he goes on to make a good point, which is that as technologists, many of us have a very strong preference for the new. We'd rather use what ultimately is an unfinished, buggy, unproven technology as opposed to something that's older, refined, and stable. Just kind of an interesting way of looking at that. Now, there is a very predictable hype cycle that I've seen again and again and again in our industry, and my peer Cote threw this out there, and I should probably pay him for this because this was exactly what I wanted to put into this talk. And he said, new technology comes out, and everyone's like, oh my God, this is so amazing, this is so radical, this is fantastic. And then a little while later, wow, this is pretty hard to use, right? And then a little while after that, you should actually never use this, especially if you're just trying to put a web front end onto a relational database. Oh, hey, look, something else. Rinse, repeat. Now, the only thing that I would really, change about this tweet is they're not measured in years. They're probably measured in months or weeks in some cases. Now, I think what's fascinating to me about this is we find ourselves constantly asking, where should we not use this technology? And this is a tough one because the only way we figure out where not to use it is trial and error. Now, I don't think this is new. If you go back to, building buildings, we've been doing this for millennia. Something tells me we weren't always very good at building buildings. I suspect the early building error rate was fairly high. And then you contrast that with what we do, which has been around for about a human generation. No wonder we haven't perfected it yet. Now there's a fantastic Calvin and Hobbes cartoon that really sums this up. And my son discovered Calvin and Hobbes about 3 or 4 years ago, which has been great because it's given me an excuse to essentially read him Calvin and Hobbes almost every night. And so at this point, I think I've read every Calvin strip at least 8 or 10 times. And I ran into this one and I recognized that this is software in a nutshell right here. How do they know what the load limit is on a bridge? Well, they just drive bigger and bigger trucks over it until it breaks. They weigh the last truck, rebuild the bridge, put the sign up. And it occurred to me that this is basically what we do in software. Hey, do you think a NoSQL database would be a good choice here? I don't know. Let's try it and find out. Oops, it fell over. I guess that was a bad idea. NoSQL databases suck. No, we just used it in a place that it wasn't the best choice. But this is how we figure these things out in many cases. We have to try them in a situation where it's not going to work to figure out that it doesn't work there. Now, the other side of this is, as developers, we have a tendency to get bored very quickly. And I don't know how much of this is we get into this industry because it sort of allows us to have kind of this ADD approach, or if you develop that sort of mindset once you get into this industry. But we're a lot like a dog chasing a squirrel. It's like, ooh, shiny thing, run after that. Ooh, another shiny thing, run after that. And I understand it because learning is what keeps this interesting. I have a good friend of mine, a golf buddy of mine. The last couple summers, he keeps bugging me. He's like, Nate, don't you think you're at the point in your career where you should really think about getting into management? And I said, well, why is that, John? He says, well, when I was your age, I could do my job in my sleep. It was getting boring. It was so repetitive. And then I got into management, and I could be a force multiplier, and I got to develop staff. I think you're kind of at that point in your career. And what I've reflected upon is I've never felt like I could do my job cold. The stuff I do today wasn't around 15 years ago. It keeps changing. And so to me, this is a good feature of our industry, the fact that you really never get bored. There's always something new to learn. There's always something new to play with. But we have to balance that against the fact that we have to deliver business value. The reason we exist is to help some business do better. Do things faster, do things cheaper, whatever it happens to be. And I can't deliver that business value if I'm constantly playing with new things, if I'm constantly experimenting. Eventually, I have to say, yep, this is the thing we're going to use. We are going to develop some expertise in that particular thing. Now, people need to understand that being on the bleeding edge means you will bleed. It's right there in the title. And so if you're using a really new thing, you have to expect some growing pains along with it. I was talking with a colleague earlier, and he told me that somebody he knew had just put, I won't mention the name of the framework, but it's very new, into production, and they had a bunch of problems with it. And I thought, well, it's like 0.04. Why would you put that in production? That seems like a risky choice. But I ran into this tweet, and I thought this was fantastic. So many of us have had this experience before. Thank you for the latest version of your wonderful feature. And you're going to break all my old code. This gives me many, many hours of enjoyment as I go through and try to figure out the workarounds. Thanks. We've all had this experience. Everything's working, you upgrade, and a whole bunch of things break. And then you kind of silently beat your head against the table and think, why couldn't I have gotten into a different career? Do plumbers deal with this kind of stuff? Probably not. There's this old adage that says, how do you know who the pioneers are? And it's like, oh, it's easy. They're the ones with the arrows in their back. And we don't necessarily want to do that to our production applications. We can't afford to do that to our production applications. We need to think more strategically than that. And yes, we do need to avoid dead platforms, but we have to balance that against the fact that I can't constantly change direction just because there's some new trending topic on Reddit or something. So the first thing I want to stress here is we do need to be strategic. We need to have some kind of a strategy. And I know many of us have attempted to employ hope as a strategy. It turns out that's not a very good one. The only positive thing I can say about hope is it's what rebellions are built on. So we have that going for us. But we need to be a lot more deliberate than that. The challenge for us is the fact that there are so many bits out there. Every time I turn around, it seems like somebody's got a new language, a new technique, a new framework. And that puts us into this situation of, man, how do you keep up with all that? This is a perennial challenge for us. Now maybe you follow some people's blogs, maybe you read books, maybe you follow some folks on Twitter, listen to podcasts, watch screencasts. You guys are spending some time with us here this week, really appreciate that. But you take a step back and you realize, man, this is a lot like being on a merry-go-round. It never seems to stop. Now, I didn't fully appreciate that when I got out of college. I was talking to one of my first managers, and I asked her one day, I said, why did you get out of technology? Why did you become a manager? And she said, I got tired of being on the technology merry-go-round. I got tired of having to constantly learn new things. Now, I will admit I was a little taken aback by that because I thought, well, you're saying like in management, there's like nothing new for you to learn? There's not like new ways of motivating people or evaluating people or something like that? It would seem like there's got to be some kind of a skill involved in that. So the challenge for us, quite frankly, is getting into a routine, developing some kind of a routine that gives you some time to explore what's coming, explore what's new, so you have an idea of where you want to position yourself, your company, your teams. So do the best you can to block out some time on your calendar. Maybe that's Friday afternoon, maybe that's Tuesday over lunch, whatever fits in your world. Now, I am a huge, huge proponent of what I call morning coffee, which is you take that first cup of coffee, the first 15, 20, 30 minutes of the day, you use that as an opportunity to catch up on what's happening in the technology space. And if you do that on a consistent basis, you'll be amazed at how many things you can pick up on. And that'll help you filter through what's interesting and what's not so that you can decide, that's something I need to dig deeper into. I'm going to carve out some time this weekend or next week or whatever it happens to be to go deeper on that. But I stress to try to do it first thing in the morning, because if you wait, the day just gets away from you. And many times I'm like, I'll do that over lunch, and then you blink and it's time to go home. And you're like, what happened? Oh, that's right, we had this big fire drill. I had to deal with this problem. One of the most important things I can stress to you in this space, though, is attention is precious. Your attention is the most precious resource you have. It is finite. The interesting thing to me these days is to see how valuable our attention actually is. And there's a great Seth Godin quote on this. He says, it's a bit like real estate. They're not making any more of it. The difference, though, is the value of your attention keeps going up. And just reflect for a minute on how many billion-dollar corporations exist to monetize and capture your attention. I mean, this is Twitter and Facebook in a nutshell right here. Capture, keep, monetize your attention. Do not waste your attention. I urge you to be selective. Any feed, anything that's clamoring for your attention, it has to pass a pretty high bar. Now, this shouldn't come as a surprise to any of you, but you cannot, in fact, read it all. I've struggled with this throughout my life, bar none. I used to subscribe to a lot of magazines, and they would basically just pile up on the island in my kitchen, and I would walk by the pile, and the pile would fall over, and my wife would give me a look that suggests now is an excellent time to go clean up the pile. In fact, I just did this before I came on this trip. I cleaned up my pile and realized that I had magazines in there that were like 3 years old. And so those went in the recycling bin, because I just sort of finally made peace with myself that if I haven't read it by now, I'm probably not going to. The reality, guys, is you're going to miss almost everything that gets produced. Now, I used to struggle with this, and then I realized that if something is a big enough deal, you will hear about it, even if you're trying not to. So take, for example, GitHub and Microsoft. Even if you don't follow the mergers and acquisition space, even if you don't use GitHub, even if you haven't used Windows in 15 years, there's a pretty good chance that you heard that, hey, Microsoft put in a bid on GitHub. So these things bubble up if they're a big enough deal. Now, the challenge for us, again, is that we cannot adopt everything that comes down, because it won't work. We just can't do that. So how do we know what we should invest in and what we shouldn't? There's one theory that says you develop a hacker's radar after you've been doing this long enough. And so Paul Graham wrote this piece called Hacker's Radar a while back. And he laid out all these principles that he sort of looked at in a new thing. And he talked about this in terms of Java. Now, keep in mind, this was almost 20 years ago. And in the writing of this article, Graham flat out says, I have a hunch that Java won't be a very successful language. Now, with, of course, the benefit of hindsight, I find that to be a pretty ludicrous statement. Now, again, looking backwards is a lot easier than looking forwards. But it's interesting to see how even someone who has been in the space as long as Paul has, who knows his way around the space, I would say made a pretty big miss when it came to Java. Now, he admitted that he'd never written a line of Java, but he'd glanced at a few books. But he said his hunch was that Java wasn't going to be a very important language. And in fairness, judging covers can be a fairly useful filter, especially if you've been doing this long enough. But we have to watch out for our own bias. Let's take JavaScript as an example. If you had a negative experience with JavaScript in the late 90s or the early, I guess we call them the aughts, the 00s, or the 10s, or earlier this week, there's a pretty good chance that sticks with you. But if you actually look at all the changes that are in play here with the next version of ECMAScript, it's a very powerful language, and it's made a lot of really good adjustments. But if you drag along that baggage from a bad experience of 10 or 15 years ago, that might bias your decision today. Now, I do think it's very interesting to look at where the community is, but we have to be careful we're not being a bunch of lemmings. I've seen too many people that just chase after something because, my competitor's doing it, or I read this white paper about some big company that's using it. And that's not necessarily the right choice for us, though. And I think too often we have this history of kind of skating to where the proverbial puck was, as opposed to where it's going. And so one of the things that I rely on is the technology radar from ThoughtWorks. This comes out periodically a couple times a year. So this is basically the thousands of ThoughtWorks consultants, all of their experience on real projects filtering up through the Technology Advisory Board. Actually, I think Rebecca's here tomorrow. She's actually a member of the tab, and it's their view on sort of what's interesting, what's coming, what's here. And every time one of these comes out, there's usually at least 2 or 3 things I'm like, I better put that on my own personal radar to keep track of as well. I think that might be useful to me in the near future. It wasn't that long ago that Google really trumpeted this 20% time concept, which said, developers get basically a day a week to work on their own projects, to scratch their own itches. And I think there's a lot of value in that. It gives us an outlet to try that new thing, but not necessarily burden a production application with it until we know whether it makes sense or not. Now, unfortunately, that has fallen out of circle, but I do know more than a few companies that have this Innovation Friday concept, which says let's take Friday or even just Friday afternoon and use that as an opportunity for people to work on some of this new stuff, scratch those itches, try out that new technology that might in fact be our basis for the next 5 or 10 years. I'm a big believer in having regular tech talks inside your organization. It doesn't have to be every week. It could be once a month. It could be once a quarter. In my last organization, I was in charge of our lunch and learn sessions, which met roughly monthly. We usually take a month or two off in the summer and a month or two off in the winter. But the idea was we had these regular recurring sessions where we'd bring in someone to give a half-hour, 45-minute, hour-long presentation, which, by the way, is an excellent experience for you, too. It's a good thing to get up in front of a crowd and give a presentation once in a while. I'm a big believer in architectural briefings. So this actually comes from my friend Stu Halloway. And basically what it says is, one person does a little bit of research and then presents that back to the team. And despite the title, you don't actually need to be an architect to do the presentation. But we try to get through things like, hey, why should we use this thing? Why is this interesting to us? What do we need to know in order to answer that question? What do we need to know in order to use that thing? And these don't need to be lengthy. This does not need to be an hour-long, 2-hour-long lecture. Half an hour, 45 minutes is plenty. These are not supposed to be in-depth how-tos, but it is trying to get beyond that initial documentation, sort of get a sense of where does this make sense and where doesn't it make sense. Now, the one thing that makes these really work is if they're participatory events. We want everybody taking notes, asking questions, bringing their own experience to bear. We all have war stories. We all have experience. We all have, this wealth of knowledge that we can draw on to help make some of these comparisons. And so it's perfectly reasonable in these sessions to say, I don't agree with you because, or I agree with you, but I know there was a technology very similar to this a few years ago. It had this issue and that issue. Does this new technology also suffer from those problems? And of course, you should be prepared to do one of these in the near future. Now, if we get past that briefing filter, it's time to roll up our sleeves, get our hands dirty, and do a little bit of hands-on workshop. So block out a couple of hours an afternoon and do a few exercises. Get beyond that sort of initial setup time, get people an opportunity to really figure out how do we use this. Now, if we get through that and we're all like, yep, this makes a lot of sense, I like what this does for us, we should look for a real project somewhere in our organization. We want to do a trial run. Now, that can be challenging because we want a real project, but it has to be a real project that has a good fit. We don't want to just sort of shoehorn it in so that we have an excuse to use it. And we also need to be very cognizant of the fact that this probably shouldn't be a bet the company kind of project. This might not be the best place to try that new experimental JavaScript framework. Now, I completely understand how fixated we all get on the new hotness, and that's a very important thing for being in this industry, for staying abreast of technology trends, keeping ourselves marketable, etc. But we also need to remember currency. I think about how many, quite frankly, months of my career I've spent on various currency issues, upgrading from this version of the operating system to that version of the operating system. And these kinds of issues are really starting to get the attention of C-level suites. When you see things like Heartbleed, and you start to realize this has a real impact on our companies. And of course, if you're a U.S. citizen, you are very aware of the Equifax hack. The fact that the Equifax folks had an unpatched version of struts running in production. Now, I still haven't figured out what the larger crime is. The fact that they had an unpatched version of struts running in production, or the fact that they were still running struts. Not entirely sure on that. That'd be an interesting debate to have, actually. So these things happen. Now, I realize a lot of us are like, oh, my company's not that interesting. We're not really a target. If you don't think you are, you should spend a little bit of time on this website, and you will see just how many attacks go on in the real world in real time. If you're having a hard time staying awake, this will probably help. It is stunning how often our systems are being poked. Yeah, and the folks that are trying to get into our systems are like velociraptors. They just keep looking for an unlocked door. They just keep trying. Now, the interesting thing here is to see how many organizations are sort of turning this on their head. You know, it used to be, don't touch production, we can't afford any downtime. And people are finally starting to understand that doesn't work now. That in order for us to be safe, we have to move faster. We have to rotate, we have to repave, we have to repair. And this is, you know, I love Justin's article, I love this quote, you know, but at high velocity, we actually starve these attacks of the resources they need to grow. What made the Equifax hack so bad is the fact that it just sat there for months. And so the adversary could just sit in there and do whatever they needed to do undisturbed. Whereas if we're constantly fixing things, it's a lot more difficult for them to get anywhere. You know, so it does flip the script, but the idea is that if you want to stay safe, we have to go faster. Speed actually reduces the risk. Now, you have to have an environment that lets you do that. And that's what's been so powerful about so many of these cloud environments these days. I was talking to a friend of mine, and he told me that in their company, they destroy and recreate their app instances every hour because they can, because it's so easy. In this way, if an adversary does happen to get a toehold in one of those app instances, the longest period of time they can go undisturbed is an hour. You know, we have clients that blow away their data center every weekend and repave it, so they always get the latest updates. That's a really powerful thing to be able to do. So as senior technologists, we better have a thought about our patching strategy too. You know, what version of that fancy library are we running? Now, I've been in organizations where we had a stated policy that said you must be at N or N-1. The challenge there is not coming up with a policy. The challenge is enforcing it. The challenge is measuring it. And I understand why we don't often do this, because it's hard. And this is actually a cultural thing more than anything, is how do we change the culture so that people stay at N or N-1? And whenever people push back on me, I always like to point out that it's a bigger issue to be the next largest hack ever. So it's probably worth your time to figure out, how can I make this culture shift so that we are not the next largest hack ever. Now, it's important to understand that every technology has pros and cons. Every technical choice we're going to make involves trade-offs. This is the essence of design. This is the essence of architecture. And so anytime somebody comes to you and says, I have this solution, this is the greatest thing ever, you should immediately start asking, what are the trade-offs? Again, this is Design 101, and I understand how the challenge can be here for us as technologists, you know, to sort of paraphrase Harry Truman, you know, please give me a one-handed technologist, because many of us are like, should we use this? Well, on the one hand, we could do this, but on the other hand, we could do that. Yeah, so React or Angular, which one should we use? Should we refactor this application to microservices? Should we be on-premises? Should we be in the public cloud? Should we be in hybrid cloud? Which public cloud provider should we go with? The longer I do this, the more I realize there's 3 answers to every question you've ever gotten in computer science. 42, that's my default answer. Another layer of indirection, that's what I say anytime I'm in an architectural discussion. But frankly, the answer I reach for more often than not is, it depends. It depends. You know, should we do this? It depends. Now, a lot of people get very mad at me when I say this, because they're like, oh, Nate, that's the end of the conversation. It's like, no, it's not. This is the beginning of the conversation. Now we have to start asking some more questions. Tell me about your environment. Tell me about what you're running into. Tell me about the problems you're facing. And the other part of this that I really think we need to get our heads wrapped around is the fact that in so many cases, we're always trying to say, should it be this or that? And the reality is, it's probably this and that. The challenge for us is figuring out when to use them. The challenge for us is figuring out how to balance this tension. Now, one of the things that I've long since discovered is there is no such thing as a perfect technology. Don't ever pretend there is. If you're bringing a new technology to me, I'm going to look for the negatives. I'm going to ask you what the negatives are. And so the way I usually try to tease this out of people is I'll ask a really simple question. Hey, what do you like about it? This should be really easy for you to answer. And I'll let you in on a little secret. I don't really care. I mean, I do, but not so much. It's the follow-up question that I'm much more interested in, which is, what don't you like about it? You better have some answers to this. Because no matter what technology you love, there's something about it that irritates you in some little way. There's something about it you would change. And usually you don't see that in the first week or two or even the first couple of months working with it. It takes time. It takes a level of experience to understand, oh yeah, that's where the rough edge is. So one of the ways I like to figure this out, and this is one of my favorite interview questions, by the way, is I'll say, hey, what would you add to this technology that you love? And this works for almost anything, language, framework, IDE. Now, before you get to add your favorite missing feature, you have to remove something first. So if I made you king of Java for a day, what feature is missing from Java that you desperately want to add? But before you can add that new feature, you've got to pull something out of the language. What's it going to be? That tends to be much harder for people to answer. So as usual, Kelsey does a much better job of summing this up. TLDR, you haven't mastered a tool until you understand when it should not be used. This is really what I'm driving at with that line of questioning. Where shouldn't we use this? Now, I strongly advise you to think about how these things stack up to the alternatives, because there are always alternatives. And so this is where we can rely on spreadsheets. Now, I'm not a huge fan of spreadsheets, although ironically enough, my life is basically in a spreadsheet these days, such is life. But you put your options across the top. You put your criteria down the left. You can certainly weight the criteria to your heart's content. I typically use Harvey balls for these things. That's these guys, from not filled in at all the way filled in. The challenge I've ever had using some kind of a numeric scale is getting people to understand which is good and which is bad. Because it doesn't matter how often you put in there, 1 is best, 5 is worst. Somebody reading your report will infer the opposite. And so using Harvey balls tends to make that problem go away, because everybody kind of understands what it means if the circle is not filled in at all. So that gets us into, how closely does this particular criteria map? I found that to be much more effective. So for example, I might put together a comparison of Angular versus React that looks a little bit like this. So I've got a whole bunch of criteria that I look at when I'm evaluating a new technology. And I give a slight nod to Angular, all things considered. Although, ironically enough, I personally prefer React. That's not to say there's something wrong with Angular. That's not to say Angular is bad. Angular is a fantastic framework. But React fits my eye better. Now, the challenge for us as technologists is, what criteria would you pick? What makes sense for you? And how should you weight them? And you know what? That's completely your call. And this is one of the things that can be very difficult for us, is to even figure out which criteria make sense. Which criteria are a bigger deal for us than others. And it's very tempting, especially when choosing or weighting criteria, to tip the scale in one direction or the other. You may have a preferred outcome. I've seen that happen before. Years and years and years ago, I was involved in a conversation about sort of UI technologies. We were kind of having this discussion about what we should adopt next. This was kind of right after struts had kind of gone out of favor. What should we do after this? We had this 2-hour conversation, a bunch of us, and really didn't get very far. We kept kind of circling back around things, and finally the senior guy said, okay, folks, let's call it a day. I'll put some time on the schedule, a week or two out. We'll come back and continue the conversation. And so we came back a week or two later, and he presented his findings on an evaluation that he had done with another senior guy. And surprise, surprise, the option that he had spent the previous meeting advocating for just happened to come out on top in the evaluation that he performed. No, I'm not saying he consciously put his thumb on the scale, but it does kind of give you pause. So in general, if you have to weight the criteria, if you have to choose criteria that makes a certain technology come out, that almost always backfires on you. It generally does not end well for you. Now, the other part of this I think is very important as architects is we need to establish principles. I remember having this project where we hardly ever saw our architect, and I thought, man, our architect's not very good. And then I became an architect and realized, man, the sheer number of projects that most architects have on their plate means we don't get to spend days with every team. We have to time slice, and that doesn't always work well. And the reality is we can't be involved in every single decision. It'd be nice, but we just can't. The best thing we can do, though, for our projects is establish a set of principles or guardrails or guideposts or North Stars, whatever you want to call them. But the idea is we want to set up our projects so that they have an environment within which they can thrive. Now, one of the things that's very challenging here is, how do we actually know if our projects are following the guidance that we originally put in place? We spend this time thinking about the quality attributes that matter for this project. We put that together and we say, well, how do we know that as you guys evolve a design, you haven't violated one of these key constructs? And that's where we get to, which for my money is one of the most powerful things we're talking about these days, fitness functions. And by the way, please ping Rebecca about this. Everybody has probably heard of the Second Law of Thermodynamics. I used to refer to this as the teenager's bedroom, because it essentially says, in a nutshell, the universe wants to be disordered. I see this myself, my desk at home. I do my best to try to keep it clean, but then I come back from a trip like this, and I sort of dump my receipts out and everything else out of my backpack, and then they overflow on my desk, and eventually I get irritated, and I spend, an hour or two or an afternoon cleaning it all up, and I'm like, okay, I got it clean, now I'm going to keep it that way. Yeah, well, I'm just fighting against, the natural law of the universe here. Now, software's not immune from this. We've all had that project where we're like, we're going to do it right this time. We're going to keep packages clean, and everything's going to be, well layered, and, we're not going to have this goofy thing where this package calls into that package, and then eventually that just sort of devolves on us. And so we put in all this effort on how to establish the architecture, and we don't put a whole lot of time into thinking about how to maintain it. And again, given that I can't spend every waking minute of my day with every single one of my projects, how do I make sure they're continuing to make good decisions? Now, again, I can't predict the future. The closest I can get to predicting the future is knowing that it will change. So knowing that things are going to change in the future, how am I supposed to define an architecture? You think about the way we've traditionally tried to define architecture. We say, well, these are the decisions that are hard to change. These are the decisions that we really wish we got right the first time. But we know things are going to change. This is the nature of software. And this is fundamentally why I think we have this sort of anti-architect backlash in the Agile community, because architecture is somehow in contradiction to Agile. I don't believe that's true, but I do think it contributes to we're Agile, ergo we don't have architects concepts. Now, as I said earlier, even if you don't have anyone in your organization with the title architect, I assure you, you have people making architectural decisions. Accidental architecture is not a good thing. Now, hopefully they're making good ones. We'll know a year or two from now how they did. Again, this is how teams arrive at having 4 separate UI frameworks. Oops. Maybe an architect or two would have helped there, or someone who felt empowered to make an architectural decision, someone who felt empowered to say, I don't think we should add yet another UI framework into our application. I think 3 is enough. So what do we do about that? Again, we know things are going to change, so how do we define an architecture that's quote-unquote resistance to change? Well, maybe we should just flip our assumptions. Martin tweeted about this earlier, and I think this is a really good way of thinking about it. We know what's in front of us, so build for that. Pick technologies that you know can evolve, and then evolve one use case at a time. That's really what we're shooting for here. That to me is the core of this concept of evolutionary architecture. There's been an awful lot of interesting things in this space. I think we're going to hear more and more about it. Again, please see Rebecca. So what if, instead of trying to define our architecture as the decisions we hope we got right, what if we designed our architectures knowing things were going to change? And that leads to this book. So Neil, Rebecca, and Patrick just published Building Evolutionary Architectures. I think this is one of the most important things we got going right now. There's a lot of good stuff in here. And I love this quote they have, an evolutionary architecture supports guided incremental change across multiple dimensions. That's what we're striving for here. Now, we all realize that some architectures are more evolvable than others. You might have a call pattern that looks something like this. Good luck trying to make that evolve with future requirements. I was talking with somebody last week. They were telling me that their application is, hundreds and hundreds of stored procedures. How do they break that down into microservices? It's like, okay, well, Step one, how did we end up having hundreds and hundreds of stored procedures? Let's talk about that. But these decisions happen over time, and we make tactical decisions, and we can't predict what the impact of that's going to be. This leads to that. There's all this butterfly effect stuff that happens to us. So maybe we need to change how we look at this. Maybe we need to think about deploying components, enabling features via toggles so that we can introduce change incrementally. I hear this a lot. I hear people say, well, we have this feature ready, but our customers aren't ready to take it yet because they're not ready to update their documentation or retrain staff. And so what do? It's like, well, you can put it in production, just turn that feature off until your customers are ready. Now, these cloud environments actually allow us to do hypothesis-driven development. How many arguments have you had in your career with somebody about, I think this will increase sales or increase conversion or help this or lower that? And you argue about it for an hour or two, and it's like, well, how about we get some real data? Let's do an A/B test on that. Let's put 10% of our customers against this changed version and see what happens. What are we trying to measure? What kind of impact do we think it's going to have? And now we're going to have real data about that instead of an argument over, I don't know. Now, again, it's important for us to make sure that our architecture continues to meet our needs as we continue to evolve things to meet new and emerging requirements. And this, again, is this challenge of, how do we know if one of those design decisions violates a key construct? And this is where I think fitness functions are so vitally important for us. Now, you probably recognize this concept. It comes out of evolutionary computing, and it basically says, is this algorithmic mutation a success or not? Are we closer to or further from our stated goals? Now, as architects, we're essentially trying to protect the ilities, the quality attributes, the non-functional requirements, and balancing those tensions, balancing those trade-offs. And so fitness functions serve a number of very useful features for us. They give us a way to actually capture and preserve those key architectural characteristics. These are the ones we care about. And so we have to identify them first. What are the key measures for this particular system that's in front of us today? You might think of these as service level indicators. What ones matter on this project? Now, it's tempting to always fall back on things we can measure. We can measure this, ergo, that must be an important thing for us. We have to be very cautious there. We can't let the ability to measure something dictate too much. Just because something is easy to measure doesn't mean it actually matters. And we've all at some point ran into someone who said, we should measure you by lines of code. Or how many lines of code did you delete this week? And not surprisingly, we'll meet that incentive. So once we understand what our metrics are, meaningful metrics, we can start to define some goals. And so now we can start talking about service level objectives. Now, a lot of people use SLO and SLA interchangeably. They're not. A service level agreement implies there is an agreement in place. There is a contract. There is a penalty for missing that service level objective. If there is no penalty, you don't have an SLA, you have an SLO. Now, again, that's a little pedantic, but trying to get the universal language as well defined as possible. Now, once we have that in place, we can start to define some fitness functions, which is really just a set of tests that we execute to validate our architecture. And so we can now measure, does this design change get us closer to or further from our stated objectives? Now, in a perfect world, these would all be automated, but there's a good chance that some of the things you care about are still going to have to be manual. So you think about anything that involves like your legal department, for instance, probably is still going to be a manual check for a while. But some examples, we might decide that all of our service calls must respond within an average of 100 milliseconds. We can write a test for that. We might decide to try to keep our code clean by saying cyclomatic complexity shall not exceed a small single-digit number. I can write a test for that. If there is a hard failure of the application, a new app instance will spin up and take its place and start serving traffic. This might be a little harder to do in an automated fashion, but it's certainly doable. And we might think about unleashing the simian army on our code base. We might think about practicing a little bit of chaos engineering. And I've thought about this before. Just imagine the meeting where this was first discussed. All right, guys, hear me out. I'm going to go down to the server room sometime this week. I'm not going to tell you when. I'm just going to start yanking out cables. Everybody cool with that? Yeah, good. I have to imagine the reception when that was first proposed was cool at best. There may have been suggestions about, why do you work here and we should fire you on the spot. That's the stupidest thing I've ever heard. But fast forward to today, and I would argue that chaos engineering is a huge part of the reason why Netflix is so successful at delivering content to us. Just think about how much of a shift that has been in our lifetimes. I can still remember being in college thinking it was really amazing that sitting in my little dorm room in central Minnesota, I could get these images to very slowly render on my computer, and then I fast forward to today, and it's like if your high def TV stream is a little jaggy, we start flipping tables. It's like, how dare you not give me 1080p over the air? And oh my God, it's a little slow on my phone. It's just crazy how quickly we change our assumptions. I had the same experience. I was on an airplane recently. That's nothing new, and the Wi-Fi was down. And I'm just like, how dare you? This is an hour and a half that I won't be connected. Things might happen in the world. And then I take a step back and I realize it wasn't that long ago that being on an airplane for an hour and a half was like this beautiful respite from the real world. No one can get a hold of you. You could just read a book or a magazine and then just chill out for 2 hours. The beauty of a fitness function is it helps us, it reminds us of what are the really important things in this architecture. What are the trade-offs that we're trying to make here? Now, there's different ways of categorizing fitness functions. Some are atomic, some are holistic. So in other words, some things that we want to test, they have to be tested in isolation. Other things, they can't. They have to be tested together. Now, the challenge, of course, with holistic fitness functions is I cannot test every possible combination. There is no way to do that, so we have to be selective. And we have to, again, let the value of that particular architectural characteristic guide us. Some might be triggered, some might be continual. So we have to think about the frequency of execution here. Some fitness functions might happen because we had a certain event happen, like every time there's a check-in, every time QA says approved. Whereas others might just happen all the time. Some people refer to this as monitoring-driven development. Some are static, some are dynamic. So some, it's like, there's a fixed result. It either passes or it fails. This is pretty much anything that we would base on a specific metric. Other fitness functions, we have a more loose definition of success. It's more of a range. So anything between this or that is fine. Now, ideally, we would have most of these automated, but some are still going to be manual, so automation is our friend. And hopefully most of these live in a well-thought-through deployment pipeline. Sadly for us, not everything is amenable to automation. Think your legal department, think your accounting departments. Existing projects tend to be a bit of a pain point here as well. We might have certain fitness functions that are temporal in nature, and so they essentially live in the code base as a reminder. And so they're basically there to say, hey, you should check to see if there's a new version of this library because they come out quarterly or they come out biannually. Oh, you did an upgrade. Well, we're going to have a break that makes sure everybody knows you did the upgrade first. Now, ideally, we're going to identify these as early in a project as we can. And as much as some people refer to that as big upfront design, I disagree. The discussion about those trade-offs is invaluable in helping us understand what really matters in this system. It also helps us prioritize. Oh, this feature is more important than that feature because of this. We might actually break the system up in a different way because of that particular discussion. Now, that said, we obviously don't know everything up front. These things will emerge as the system evolves. That's natural. So we do our best. And then we understand that things will change over time. We'll iterate on that. Imagine that. It's interesting to classify these fitness functions as well. Some might be key. These are critical decisions. We really want to make sure we get these right. Some might be relevant. We think that it's important, but it might not really influence the architecture. It's also useful to keep track of not relevant. Yes, this might be interesting, but it does not matter in this particular architecture. And the longer I do this, the more important I think it is to identify those non-goals, those non-relevant dimensions, so that when people start bringing them up, you can say, remember we had that conversation, we decided that didn't matter on this project. I strongly advise you to keep these visible. I strongly advise you to review them on a regular basis. Are they still relevant? Is there some new dimension we want to track? Is there a better way to measure that particular fitness function? I would say this should be done at least annually, if not more frequently than that. To wrap this up, guys, this architecture thing is a lot harder than I thought it was going to be. There's a lot of things for us to juggle. It is vital that we think strategically. It is vital that we avoid resume-driven design. I wish you luck. Thank you for your attention. I appreciate it.